Hi everyone, welcome to the math tutor. In today's video, we'll learn about relation and function. We complete this section in two videos. In the first video, we deal only relation and types of their relation, types of relation, and in second one, we learn about function and their types. So before going to relation, first we have to learn about Cartesian product. What is Cartesian product of sets? Okay, so what is Cartesian product? Suppose A and B are two non-empty sets. A and B are non-empty sets. Then Cartesian product A cross B is the set of all ordered pair of elements from set A to A and B, and which is defined by, that is, you can rewrite as A cross B is equal to set of all AB such that A belongs to A and small b belongs to B. For example, let A is the set where elements are 1 and 2, and in set B the elements are small a, b, c. Then what will be the Cartesian product? This will be, we consider all the paired one element from the set A and one from set B. Okay, so first we take 1A, similarly we take 1B, similarly 1C, and so on, and also 2A, 2B, and 2C. So this set of all ordered pair is called Cartesian product of A cross B. Cartesian product of A and B. Now we define relation. Okay, relation. What is a relation? A relation R from a non-empty set A relation R from a non-empty set A to a non-empty set B is a subset of the Cartesian product of A cross B, the Cartesian product of A and B, which or symbolically can write as R is a subset of A cross B, subset of equal to A cross B. Okay, this subset which is relation is a subset. This subset describe a relation between first element and second element of the order pair. Order pairs. Okay, that is here all elements are like AB, or A belongs to A and B belongs to B. So relation describe a relation between this A and B. Okay, how this first element is related to the second element. And here the second element, is called the image of first element, the image of first element. Now we'll learn some basic definition, basic term regarding relation. Okay, so first one, what is the domain of a relation? What is domain of R, which symbolically written as dom R? Okay, what is the domain of the relation? The set of all first element of R is the domain of R. The set of all first element of the set of all first element of the order pair of R is called domain of R. Then what is range of range? Symbolically we write Rn G, range of R. Oh, what is the range of R? The set of all second element. The set of all second element of the order pair of R is called range of R. And what is codomain? The set B is called codomain. Now we'll see an example. Okay, suppose in the first example we have Cartesian product this. Okay, so I am taking a relation, which is a subset of A cross B. That is, I am taking 1A, 1B and 2B, 2C. So what is the range? Range of R. What is domain of R? And what is codomain? The codomain is the set B, whole set B. But what is the domain? Oh, sir, what is the range? What is the domain? Domain is the set of first element 1, 1, 2, 2. So domain will be 1 and 2. And what will be the range? Range will be the set of second element. What is A, B, B and C? So range will be A, B and C. So this is all about range, domain and codomain. Now we have a note, that is how many relation can possible from a set to B. Okay, तो क्या कितना टू रिलेशन पॉसिबल हो सकता है कि ए और बी के बीच में? तो जितना टू सबसेट बनेगा उतना ही रिलेशन बनेगा, बिकॉज ईच सबसेट इज ए रिलेशन. वी डिफाइन द रिलेशन एज every non-empty subset, every subset of the Cartesian product A cross B is a relation from A to B. So जितना ठो A cross B का सबसेट बनेगा उतना ठो रिलेशन भी बनेगा. So we have a formula about the number of subsets. Okay, if a set A, suppose a set A has n number of element. Number of element of A is suppose B. Okay, then A has number of subsets. Total number of subsets will be 2 to the power B. So here we are discussing about number of subsets of A cross B. A cross B का जितना तो सबसेट बनेगा उतना तो ही रिलेशन होगा. So let if number of elements of A is P and number of elements of B is Q, then number of elements of A cross B, what will be the number of elements of A cross B? Is the product of simply product of number of elements of A and number of elements of B, that is PQ. So how many subsets will be formed in the set A cross B? So number of subsets or we say relation will be 2 to the power Q. This is important formula. Okay, now we'll learn about types of relation. Learn about the types of relation. So what is the empty relation? The term empty clearly defines the relation. Okay, that is if a relation has no element, that is we know that phi is the subset of every set. So phi is also a subset of A cross B. So the relation phi is called as the empty relation. Okay, and what is the universal? Next is universal relation. So what is universal relation? We know that every set is a subset of itself. So A cross B is also a subset of A cross B. So the relation A cross B is called the universal relation. Basically, we classify the relation in a two way. Okay, in the first way, when a relation is defined on a set, that means if a relation R is defined from A to A, that type of relation has a different classification. And when a relation is defined from a set A to B, that is, suppose if a relation defined on a set A, defined on a set A. That means, that is, if R is a relation from A to A, okay, sorry, if R is a relation from A to A, this type of relation has a different classification. And if a relation R is defined from the set A to B, this type of relation has a different classification. Okay, we will learn one by one. So first we consider this type of relation which is defined on a set. A relation defined on a set. This type of relation is classified into three categories. One is reflexive, second one is symmetric, and third one is transitive. So what is a reflexive relation? If order pair of A and A belongs to R, for every A belongs to R, every A belongs to A, then we say the relation is reflexive. Then what is symmetric? If AB belongs to R implies that implied by BA belongs to R for all AB belongs to A, then we say the relation is symmetric. If for all AB belongs to R, the order pair BA also belongs to R, then we say the relation is symmetric. Then what is transitive? If AB belongs to R and BC also belongs to R, this implies AC also belongs to R for all A, B and C belongs to R. Okay, if A and B belongs to R and B and C belongs to R, and then it implies if AB belongs to R and BC belongs to R implies that A and C belongs to R, then sorry, for all ABC belongs to A, sorry, for all ABC belongs to A, then we say the relation is transitive. Now if a relation is reflexive as well as symmetric as well as transitive, then the relation is called equivalence relation. So what is equivalence relation? It is a special case. Equivalence relation, a relation R is called equivalence relation if it is reflexive as well as symmetric and transitive. Okay, so suppose we have an example. Let we have a relation, we have a set A. Okay, set A has 1, 2 and 3, and I am defining a relation on relation on A, that is 1 1, 2 2, 3 3, 1 2 and 2 3. Now we say that whether it is reflexive, symmetric or transitive. So to check reflexive property, we will check that for every A we have order pair A in R. So for every A, that is for 1 we have 1 1 in R, for 2 we have 2 2 in R, for 3 we have 3 3 in R, so R is reflexive. Now for symmetric, for AB belongs to R, we have to BA also belongs to R. Okay, so here for 1 2, here for this case for 1 2 we have 2 1, we should have 2 1 in the set R, but since we have not 2 1 in the set, this is not symmetric. If 2 1 is in the R, then 2 1, and also for this case 2 3 we have to, for 2 1, sorry, if 2 1 and 3 2 are in the set R, then we can say the R is symmetric. So not symmetric. And for transitive case, for all AB and BC we should have AC. So here in last two term we clearly see that for 1 2 and 2 3 we should have 1 3 in the set, but 1 3 is not present, so it is not transitive. Since it is not symmetric, not transitive, only reflexive, it is not also not an equivalence, not equivalence. Okay, so I have a homework for you all, that let a set be set of all line, that A is the set of all lines. Okay, and I am defining a relation R on A, that is L1 L2, such that L1 is perpendicular to L2. So you have to identify that whether it is reflexive, symmetric or transitive, or equivalent relation. Okay, so this is a homework, and now we discuss the relation which is defined from a set to another set. Okay, this type of relation is mainly classified into 4 categories: 1 2 3 and 4. That is one is the 1 1 relation. If each element of A, if every element of A has a unique image in B, if every element if in R, every element of A has unique image in B. That is, for example, suppose 1 2 and A B C. That is, if 1 related to A, 2 related to B, this type of relation is called 1 1 relation. This is also 1 2 3 and A B C also there. Here 1 2 related to it, 2 related to it. This is also a relation. This is also a 1 1 relation. then one many. So this term clearly says a definition that if in our every element of each element of A related to more than one element of B, one element of B, that is suppose 1 2 and ABC, that is one related to A also, one related to B also. This type of relation is called one many. The third one is many one. So this is the also similar, that is if in our many elements of A have unique image in B, that is suppose 1 2 and here A B C, here 1 also image A and 2 also image A. This type of relation is called many one relation, and the last one is many relation. So what is many relation? If many elements of A, if in relation are many elements of A related to many elements of B, that is suppose 1 2 3 A B C, one related to A, one related to B, similarly two related to A, two related to B, two related to C. So this type of relation is a many to many relation. Okay, one has many images, two has many images. Okay, this is all about relation and types of relation. Any doubt, any query, please comment. Okay, thank you.